My name is Neora, and this is my lab video report on Lab 4 about bar magnets. The video contents will be introduction, related concepts, experiment, computer model, and discussion. Introduction. The purpose of this lab is to apply the principles of magnetic field to calculate the strength of the magnetic field of a bar magnet and recreate it using a computer model. The result: the magnetic dipole moment that we calculated was 0.8211 ampere times meter squared. And here's a preview of the experiment. As you can see, the left image is the graph, the natural log of R against natural log of B, the magnetic field. And right image is the image of the computer model that I've created for this experiment. Related concept for this one was magnetic field of a bar magnet, which is K times R to the nth power. And since you will see in the future, magnetic dipole is being calculated. Here is the formula for the magnetic field for that we used in this experiment. The assumptions that we made for this experiment was that bar magnet behaves as a magnetic dipole. There is no interference from other metal or magnetic objects. And the system for this experiment was the bar magnet and the surroundings, everything else. Procedures, as you can see: align the phone so Bx equals 0 and set the meter stick east-west. Place the magnet along the meter stick and locate the sensor. Measure R for, well, there's a typing mistake. Target Bx values 20 to 220 microtesla, taking 3 trials each. Then we made the average of those trials and plotted log of R and Bx to find the slope and dipole moment. Measured the field at 45 degrees, correct for Earth field, and compared it to the theory. The results, as you can see, is like this. We measured the result for on-axis and off-axis results, and the results are organized in a spreadsheet, and on the right you can see the graph. Here is the GlowScript code of the computer model that I've created, and when you run the code you can see that it represents the magnetic field in arrows, as you can see, and the top right small magenta arrow is the off-axis. Possible sources of error for this experiment is error in magnetometer, human errors in reading the calibrations of the meter stick, and many other things, maybe like shaking hands when measuring was happening, and the assumptions that we made at the beginning of the experiment not being true. Discussion: what if you had not oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your result have changed? The Earth's magnetic field would have, there's a typo again, would have added to magnetic bar's dipole, and therefore the measurements would be much more dirty and unorganized since it is interfering with the phone's magnetometer that we were using. What if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? When we are using 2 identical magnets, the magnetic fields would add up, therefore B would be doubled and R would increase also to match for the value of B. Although they would double in magnitude, the slope of the graph of natural log R versus natural log Bx would not change and stay the same. Conclusion: we successfully calculated the magnitude of magnetic field of the bar magnet and successfully recreated the experiment with a computer model. Thank you.